All right, hello everyone. My name is Glenn Ritchie. I've helped out as a superintendent for the agronomy CDE for several years now. I apologize that I'm not seeing all of you in person this year. The agronomy CDE happened to overlap with a national competition that we're participating in with the crops team at Texas Tech. So I'm actually in Twin Falls, assuming that I've traveled there safely. But I wanted to spend a few minutes going through the solutions for 2024 and walking you through things to focus on. Just to show you that we're working on the same document here, your solutions and assessments should look a lot like this. I'm going to spend most of my time in Excel just because of the calculations. I may hop back for the assessments and we'll take a closer look here. So without further ado, the first thing that I always recommend that you do before you take the exam is look and see what instructions you have, see what resources you have available to you. I initially was not going to include the part that says that 1 acre is equal to 43,560 square feet because you could theoretically calculate it by taking number of feet in a mile, squaring it, and dividing by 640 if you were trying to remember. But I thought it feels like I'm just purposely trying to make the contest a little bit more difficult. So you're welcome. For those of you who memorized it, the nice thing is you'll know it in the future when you need it. So jumping into question 1, it should look something like this. A center pivot has 12 spans, and each span is 140 feet long. There's no end gun, and the pivot travels in a circle. Apparently I forgot to delete my answers here. So how many acres does the pivot cover? So I'm going to start out by envisioning what does this pivot look like. It's going to be circular shaped. And so all of the calculations should come back to a circular area here. On the conversions here, I see that the area of a circle is pi r squared. So in the end, I'm going to need to do pi r squared at some point to get the area here. But let's start out and figure out what our radius is here. So imagine this, this long pivot here. This pivot is not the diameter of the field, it's going to be the radius of the field. And then it's going to spin around in a circle and it's going to cover the radius around the entire circle track here. So the span length is 140 feet. There are 12 spans. To get the total length of the radius, I'm just going to do the span length times the number of spans, and that gives me 1,680 feet for the radius. The total area in square feet is simply going to be pi times the length squared. If you can't remember pi, use 3.14. Your calculator probably has that on there. I don't actually have a shorthand of that, but I feel like that's something that's in general knowledge here. So 3.14 times this squared gives me my total number of square feet, and then I need to divide my total number of square feet by the square feet in an acre, and I get 203.5 acres. So looking at my answers here, that's not going to be 180 or 220 or 240 or 0.240. It's going to be 200. By the way, I try where possible to include logical answers, also ones that might be a little bit misleading. So just because you see something like, oh, well, is it 240 or 0.240? I'm doing that in case someone didn't do the calculation and they're like, okay, well, it's one of these two. In this case, it's not one of those two. All right, moving on to question 2. I'm spraying a rectangular field with a length of 2,000 feet in the direction I'm spraying. My spray volume is 15 gallons per acre. My tank's 500 gallons. I'm driving, etc., etc. My boom's 60 feet wide, and a container of glyphosate is 2.5 gallons. This is one that has both useful and extraneous information. And the nice thing is, next year I could use the same question and just use parts of this that now become useful that are currently not useful. But I need to figure out how many passes I'll be able to make before I refill the tank. So I need to figure out how many acres I have in a pass and then go from there. I know that the width of my spray boom is 60 feet. I know that the length that I'm spraying is 2,000 feet. So I'm going to go ahead and put that in, and that will give me my area that I'm spraying with each pass. So 60. So to get this, I just do my length times my width, and I get 120,000 square feet. Let's go ahead and convert that to acres by divided by 43,560. So each pass I'm spraying about 2.75 acres. Now I am not just spraying 2.75 gallons, I'm actually spraying the number of acres times 15 gallons per acre. So I'm spraying about 41 gallons out of my tank each pass. Now all I need to do is figure out, with a 500 gallon tank, how many times can I spray 41.3 gallons before I run out. So all I have to do is 500 gallons divided by gallons per acre is going, actually I'm skipping a step here. I'm jumping right to the answer here. Gallons per pass is going to be my area in acres times my gallons per acre. I feel like I skipped a step on here. Let me back up just a second here. I guess I should read what I have on the right hand side. I'm spraying 15 gallons per acre. Multiply that by the number of acres per pass, and that comes out to 41.3 gallons per pass. And now I can do the 500 gallon tank divided by the number of gallons per pass, and that gives me the number of passes that I can make, which is about 12. It's slightly more than 12, so I don't have to worry about asking myself, well, what if I run out, 500 feet before the end of the pass? In this case, I should have just enough to be able to spray these 12 passes. And I didn't include 11 here because I didn't want you to say, well, with overage, maybe you could only spray 11 complete passes. In this case, there's only one logical correct answer. All right, moving into question 3. A producer is planting a 7,000 foot wide field with a 16-row planter that plants 40-inch rows. How many rows will be planted, assuming that the planter will not make a pass unless all the rows can be planted? That's going to be important in a minute. So if we have a fractional pass at the end, we're not going to be able to plant it. So how many rows do we have? 16. The row width is 40 inches. I'm going to go ahead and convert that to feet because I've got to figure out, in terms of feet for the rest of the answer here. So 40 inches divided by 12 inches per foot can be 3 1/3 feet. Now my planter width is simply going to be the number of rows times the number of feet per row. And so our planter is 53 1/3 feet wide. Our field is 7,000 feet. That comes from the question. And so my number of passes, I would be tempted to do the following. I would do 7,000 feet divided by 53 1/3 equals 131.25 passes, and then simply take that times the number of rows on the planter, and 2,100. Looks like a great answer. It's even listed here. So I answer 2,100 and I go upon my merry way. However, as I mentioned, we cannot make a pass if we're not covering all 16 rows. This 0.25 indicates that on our very last pass, we would only be able to cover 4 rows. So you may either divide or subtract 4 rows from 2100, or you could do 131 times 16. Either way, you're going to get 2096 rows, which is answer C. Moving on to question 4. I'm purchasing glufosinate, which is Liberty, in advance of the growing season to spray at an average rate of 30 ounces per acre on a 2,300 acre farm. Here's my spray volume, my tank size. A container of glufosinate is 2.5 gallons. A pallet holds 72 containers. And I get a 5% discount for ordering by the pallet. And so if I'm close to having a full pallet, it's probably going to be less expensive to buy a full pallet than it is to buy the container or buy the box. So I would say if I'm less than 5% from having a full pallet, then I should probably just buy a full pallet. All right. It's also a lot easier because, you know, they deliver the pallet where you want it and you're not having to load up the back of your truck with a bunch of boxes of herbicide. So let's see what we get and see if that ends up being an issue. Spoiler, it probably is. So my glufosinate rate is 30 ounces per acre. My total number of acres is 2,300. So my total ounces of glufosinate that I need are simply going to be 30 ounces times 2,300 acres. Now that's useful, but it would sure be nice to be dealing with it in gallons. So let's go ahead and take the number of ounces divided by 128 to get gallons. How did I get that? Well, back to my conversions here. An ounce is, that's not important, but a gallon is equal to 128 fluid ounces. Wrong question. Okay, still wrong question. All right, so this is the number of gallons that I'm going to need to apply. So how many containers do I need? Well, let's divide the number of gallons by 2.5 because that's the number that we have in each container. So that puts us at 215 containers, which I still don't see as an answer because I'm not asking for it in terms of containers, I'm asking for pallets here. So now I'm going to take the number of containers divided by 72 containers per pallet, and we get virtually 3 pallets. And you might say, well, you know, this is technically less than 3 pallets. This is only 2.99 pallets. However, because we're within 5% of having a third pallet, it makes a lot more sense to purchase a third pallet and save that 5% there. And also, you know, 2.99 rounds are very close to 3. Not saying I did that on purpose, but I kind of did that on purpose. All right, moving on to question 5. I'm planting corn on 30-inch rows and have a target planting rate of 28,000 plants per acre. How many seeds per foot should there be? And by the way, you may notice that the answers that I have listed here are not exactly the same as the answers that I have listed here. Let me go see if I can find that one. Okay, we're going to close your eyes for a moment. Okay, open them. All right, now it looks identical. I actually changed answer A, which is one of my incorrect answers, because it would match to part of our calculations here. So just me trying to, you know, make sure that you go through all your steps here. So my total population plants per acre is 28,000. That's given. My population per square foot is simply going to be my total population divided by the square feet in an acre. And In this case, it's 0.64, which matches up with answer A. And so I hope you didn't stop there. If you did, I'm sorry. If you're in a real world situation and you stopped at that point, you just overplanted, or underplanted, I guess, in this case. My row width in inches is 30. My row width in feet is simply going to be 30 divided by 12, which is 2.5. And so my area per planted foot is not 1 square foot. It is actually 2.5 feet one direction by 1 foot the other direction. Uh-oh. I hope that my... Okay, it says it's still streaming here, sorry. So 2.5 one direction. Actually, before I do that, let me go ahead and change this to 2.5 feet. Now, 2.5 feet times 1 foot equals 2.5 feet squared. So I need to figure out my seeds per 2.5 square feet rather than my seeds per square foot. So I'm just going to do my population per square feet times my number of square feet, and it should be about 1.61. I put 1.60. It's within rounding error, and it's much closer than these others are. All right, moving on to question 6. I have a 310 acre field, so I'm going to go ahead and put that in here. Harvested a total of 913 tons of wheat, and I need to figure out what my bushels per acre is. So let's go ahead and convert this tons to pounds, and then a bushel of wheat is considered 60 pounds, so I'm going to do that divided by 60, so that gives me my total bushels. Hopefully you don't immediately say, oh, hey, that looks like one of my answers, and pop that in, because we still need to divide by 310 acres to get my bushels per acre. So it should be about 98 bushels per acre. Okay, question 7. I'm purchasing 28005 fertilizer, and I plan to fertilize an average of 120 pounds N per acre to my 700 acre farm. It's sold by the ton, so how many tons do I need to order? So let's go ahead and plug in what we have here. I'm doing 120 pounds of nitrogen per acre. I've got 700 acres. All right. How many pounds of nitrogen do I have per pound of fertilizer? You will recall that this first number is the nitrogen content, so 0.28 pounds per pound. If you get more nitrogen than you have total fertilizer, you're probably going the wrong direction here, so just keep that in mind. So my pounds of fertilizer per acre is going to be my pounds of nitrogen per acre. Don't be tempted to do times 0.28, because essentially you're saying that you're applying 120 pounds of nitrogen with 33.6 total pounds of fertilizer. Instead, you actually need to divide by the percentage nitrogen. And so we've actually got to put out 428 roughly pounds of fertilizer per acre. We've got to do that over 700 acres, so I'm going to do pounds per acre times the number of acres. Now I need to take my total pounds of fertilizer and divide by the number of pounds in a ton, which is 2,000. If you're uncertain, I think we have a conversion there. Yep, 1 ton equals 2,000 pounds. So I get 150 tons of fertilizer, which is answer C. Okay, question 8. Below is a spray nozzle chart for a T-Jet XRC nozzle. If I'm spraying at 40 psi and capturing spray for 30 seconds, how much spray should I catch from a single nozzle? So I start by finding 40 psi here, which I have labeled here. All my answers are going to be in this column, more or less. But be aware, you need to take one thing into account here. Okay, how many ounces per minute do I have? 26. Now, am I capturing for a minute? Nope, I'm capturing for 30 seconds. So my value is going to be half of this. So it's not going to be 26, it's going to be 13. So I immediately know that it's either going to be answer C or answer E. And now I look over at which of these is closest to 10 gallons per acre. 14.9, no. 11.9, no. 9.9, well, that's pretty close. 7.4, we're getting further away, so my answer is going to be this one. I look up here and I see 6 miles an hour. So 13 ounces, 6 miles an hour. Okay, question 9. Takes 13.3 pounds of grapes to produce a gallon of wine. A grape producer has 8 acres of grapes and traditionally produces 1.4 tons per acre. How many gallons of wine does she produce on average? So let's go ahead and plug in 13.3 pounds per gallon of wine. 8 acres, 1.4 tons per acre. All right, so how many total tons does she produce? Well, 1.4 tons per acre times 8 acres is 11.2 tons. We need to convert that to pounds, so times 2,000, which we used in the last problem. Now it takes 13.3 of those 22,400 pounds to make a gallon. So I just do this divided by 13.3 and we get 1684 pounds, which looks an awful lot like answer A. All right, question 10. A soil test recommends 170 pounds of nitrogen, 80 pounds of P2O5, and 80 pounds of K2O per acre. Be aware in this case, if we put elemental P, you would have to do an additional conversion. If we did elemental K, we would have to do an additional conversion. For purposes of this, we decided not to have you do that additional conversion. So let's jump into this a little bit here. It would be tempting. The way that you get the pounds of fertilizer is simply take the pounds of product that you need, divide by the percent. So it would be tempting to simply go, okay, I need 170 pounds of nitrogen, divide that by 0.46, and now my nitrogen is completely squared away. I need to put out 170. I'm now putting out 170. Let's move to the next one. I've got to do some phosphorus. So we need 80 pounds of phosphorus divided by, let's see, that's 0.52. And now we're perfect on the phosphorus. Well, look what just happened on our nitrogen. Now we're over applying it because you've got to start with whatever you absolutely need to apply and then subtract that on something that has more than one element in here. So let's step back and do this right. So starting with our phosphorus, which is the one that we are in limiting supply, and we can make up the nitrogen with this 4600. I'm going to do the pounds of phosphorus we need, which is 80 divided by 0.52. Put that in here. So we need 154 pounds of 1152O to put out the right amount of P2O5. So I'm going to put in 154 pounds. All this is doing is dividing it by that 52%. Now I also need to do that with the nitrogen, so I take 154 pounds times 0.11, and that gives me about 17 pounds of nitrogen here. So I know that for my nitrogen, I need to do, my need is not 170 anymore, it's actually 170 minus, I'm just going to round to 17. Now I divide by the 0.46. That gives me about 333 pounds of this. So I'm going to pop that in here there. So just to look at here, I immediately know that it's going to be either B or E in this case. I also know it's going to be E in this case because we already calculated that we needed to do 154 pounds here. So I already know the answer is E, but let's verify that it's working out with our potassium here. So using the same strategy, muriate of potash is 0.0060. I need to put out 80 pounds, so I'm going to do 80 divided by 0.6, and hopefully that comes out to 133 pounds. Ooh, it does. Now, looking at our answers here, we've now applied 170 pounds of nitrogen, 80 pounds of phosphorus, and 80 pounds of potassium. I'll do this down here. So I said that was 80 divided by 0.6, and lo and behold. So my final answer is I need 333 pounds of 4600, 154 pounds of 1152, and 133 pounds of 0060. All right, let's take a peek at the other half of it here. Okay, what did you use to calculate the area of the center pivot in question 1 of the solutions? Area of the circle. In determining the answer to question 2 of the solutions, which of the following information is not extraneous to the question? Well, we use the pass width, which is the boom width. Okay, in question 3 of the solutions, which of the following could not be planted with a 16-row planter without overlapping or running outside of the field? So what we have to do is do the number of rows divided by 16 and see if we come up with a whole number. So I'm just gonna, you can do pretty much the same thing with the calculator. I'm just gonna plug in these numbers, divide by 16. 104 doesn't work. 144 does work. Let's check the others. 224 works, and 256 works. So 104 rows would not work in this case. Okay, based on question 4 of the solutions, how many ounces of glufosinate would be in a container, sorry. So let's look at question 4 here. Okay, apparently I was calculating this on the wrong page. That's okay though. Question 4, a container is 2.5 gallons, so 2.5 times 128 is 320 ounces per container, which is answer C. How many feet would 30 inches be? Well, 30 divided by 12 is 2.5. How many pounds are in a US ton? Well, that's given to you at the beginning. Hopefully you noticed that. How many pounds of nitrogen are in a gallon of 28005 fertilizer? So let's see, that's question 7. So you'll notice that in our gallon of fertilizer, it's 11.1 pounds per gallon. So we've got to do 11.1 times 28% or 0.28, 3.1 pounds in a gallon, so B. Okay, if a reasonable relationship between PSI and ounces per minute is gallons per minute equals 0.0027 times PSI plus 0.0864, how many gallons per minute would you expect if the PSI is 45? So all we have to do is plug in 45 into the PSI here. Equals 0.0027 times 45 plus 0.0864. You didn't know you were doing algebra today, did you? So I got about 0.208, which would be C. Final answer. Okay, if the number of acres doubled and the total tons of grapes harvested remained unchanged, what effect would this have on the yield? Well, if we're still producing the same amount of product on twice as many acres, we just lost half of our yield, so divided by 2. Okay, if urea costs $600 per US ton, how much is the cost per pound of nitrogen? Ooh, this is going to be kind of a fun one. Not super difficult, but you've got to walk through a couple of steps here. So first of all, 600 pounds per ton, if we divide by 2,000, it seems like it's going to be 30 cents per pound, right? But I don't see the answer of 30 cents per pound here. There we go. What you have to keep in mind is we're not measuring the price per pound of product, we're measuring the price per pound of nitrogen, and it takes more than 1 pound of product to make 1 pound of nitrogen. So you've got to divide by 46% or 0.46, which comes out to about 65 cents. If I add decimals, 0.652 cents per pound of nitrogen. Now you may say, why are we showing past the cent? Well, because we're buying so much of it, that next digit becomes important in that case. So the answer is going to be D. I hope you've enjoyed this. I hope you enjoy your time in Lubbock, and we look forward to seeing you next year.